It's Z890 time, chat. You're gonna have to let me know that you can hear me okay. I've got all the Z890 because, unboxings, let's make it live. Let's ask questions. And it can even be like random tech support questions because I don't care. I don't get the chat. I'm looking at the chat over here. So it's live and there's things happening. And right now there's only like 72 of you, so it's fine. Frenzied Man Beast says poggers. Awesome Arizona says live. Sounds good. Loud and clear. Well, that is fantastic. Z890. In case you didn't know, Intel is launching some new CPUs, and things are different and slightly weird this time. And yeah, that's just a lot of fun because, yeah, obviously it is. Why wouldn't it be? Because Z890. It's not LGA 1700. These are new CPUs. These are not even CPUs. There is no chance that any of these CPUs will have any marginality or vmin shift or anything like that. Any problems remotely related to any of the previous problems, which is fantastic because it's a fundamentally different process under the hood by a lot. And the first one I have is the Z890 Taichi, which has Thunderbolt 4. This is the Taichi Lite, by the way. If you've been living under a rock, ASRock does the Taichi and the Taichi Lite. And the Taichi non-Lite version, generally the RGB and the decoration on the board, maybe there's an active cooling backplane or something like that. That's the difference. Electrically, they're the same. And so if you're curmudgeonly or you don't care about RGB, you can literally buy exactly the same motherboard electrically, performance-wise, and it costs less because it's the Taichi Lite because it doesn't come with any of the RGB stuff. What's the new LGA? That's what these are. Oh, and check this out. I can do this with the camera. How cool is that? Is audio still good with that? So look, there's the Z890. Then I can do this, and then you can see what's going on in the box. This is the RGB breakout cables and the Wi-Fi 7 antenna because it comes bundled with Wi-Fi 7. How glorious that is. I can't do performance today because that's still under embargo. I can only do the unboxing. So yeah. All right, let's see. There we go. All right, for the rear I/O, you can probably follow along with the web page. It's got 5 gig and 2.5 gig Lightning, USB. We only got 2 USB 2.0 ports, looks like. But actually, those might not be. Well, yeah, they're USB 2. They look like they're wired. The USB 2 ports have the extra pins, but I'm sure that they're USB 2. So there's only 2 USB 2 ports. The other 8 are faster. The 2 at the back here, you got your 2 Type-C Thunderbolt with display out plus HDMI. That comes from the iGPU. Now, it's interesting on the boxes for these, they don't actually advertise a memory speed. I've heard, I don't know, because you can't talk about actual real world performance, but theoretically, over 10,000 mega transfers. Also really interesting if you follow along, a lot of these motherboards were on display at Computex in June. There've been some revisions since then. But look at the M.2 heatsink. Let me switch to the other angle. Look at this. Above. Yoink. See my M.2? Look at this. This little slidey thing. Just this little slide dot, and then boom, it pops off. It's toolless. I know all of you in the audience are super fans. You've been following me for a long time. You know that I have this bad habit of not screwing M.2s down. I do actually screw the M.2s down, but I love doing that for a video. 1, because engagement challenge, but 2, because eventually it leads to innovation like this. People say, the engineers say, you know what? Everybody hates screwing down M.2s and losing the tiny screws. It only took way more generations than I thought to see features like this, but yeah. And there's more M.2 lurking under here. We've only got the 2 physical expansion slots on this, and it's an X4, it's an X16. So yeah, and then there's, you know, there's another 2280 and another 2280 and some more under here. So you got lots of M.2 connectivity, and a 30-pin USB header at the front and a Type-C header at the front. Got 3 4-pin fan headers, another 4-pin fan header at the back. And you got an external TPM header, digital and analog RGB headers, audio. Got 4 4-pin fan headers at the bottom. A lot going on this board. It's very heavy. Dual 8-pin power. Wi-Fi 7, as I mentioned. Plenty of cooling for the Wi-Fi 7 as well. There is no active fan. That's good. Some people will not buy a motherboard if there's a fan on the VRM, a little fan. This one does not have that. Interestingly. There's also a plastic sticker on the board here that says Memory OC Shield. So they put some plastic down here, interestingly. Yeah, LGA 1700. No protective thing on the back of the board. Let me catch up with chat. How's the bifurcation in that X16? Theoretically, again, wouldn't know. Theoretically, Arrow Lake's bifurcation support is better, but you're still going to run X4, 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 X4. Theoretically, it supports X8, X4, X4, but it's only theoretical. This is just an unboxing. And yeah, it has a 7-segment display at the top, which is nice for diagnostics. And it's got a physical power and reset button, which is amazing. Neat. It's also got a cool little protector for your E-key Wi-Fi. So this E-key Wi-Fi is actually really accessible. Sometimes they hide it under here and you got to take all this off to get to it. I like that it's here because this is a lot more maintainable. It's like, I'm going to put in Wi-Fi 9 and not actually retire this motherboard in several generations. Well, it's pretty accessible to replace the Wi-Fi card, and the antenna wires are right there, and they're modular, they're not soldered. It's fantastic. It's a perfectly reasonable motherboard layout. TechSoup says something Thunderbolt 5. This is not Thunderbolt 5, it's Thunderbolt 4. There are some boards that have Thunderbolt 5. This is not one. PCIe lanes, yes. All right, let's see what else we got in the box bundle. All right. Got a Taichi cherry style stem keycap. Got your installation manual and your guide. Your real manual is online. Oh, it says, do not remove the memory OC shield, patent pending from the motherboard. Removing this may affect memory overclocking performance and stability. So it's like a little foil shield sticker thingy. We're going to need an ASRock overclocker to tell me how legit that is, because I'm skeptical somewhat. Fortunately, I know some of those guys, so I got to send an email after the stream. Dual SATA cables, another dual SATA cables. Analog temperature sensor, another analog temperature sensor, another analog temperature sensor, some M.2 screws for the ones that we saw that did not have a heat shield, which is actually pretty good, because sometimes you get an M.2 that, you know, has its own built-in heat shield, and then taking that off, there's a chance of damaging it. I'd rather not do that generally. I like the M.2 layout on that board. You know, some of your M.2 are underneath your GPU, but having the M.2 also at the front edge of the board for your PCIe Gen 4 M.2. Okay, that makes sense. And the one up here is Gen 5, so the one below the CPU socket, it's rated for Gen 5. Now, we've also got the Phantom Gaming Nova, which is very, very similar, as it turns out. Look at that. Is the ASRock TRX50 good for Linux? It is indeed. But this is the Z890 stream. Z890 Nova. Cam 2 support. None of the boards that I have do Cam 2, but these boards do work with CU DIM, which is how they do absurdly fast speeds. So this is your M.2 layout. You can kind of see it in the corner. You got the Gen 5 and then Gen 4, Gen 4, Gen 4, Gen 4, Gen 4. You could also do a bundled M.2 expansion card in the Nova. So that means that the Nova's bundle is fancier than the Taichi's bundle. Well, that was the Taichi Lite. But look, Wi-Fi 7, 5 gigabit Ethernet, BIOS flashback for future support. Very similar layout here, USB 2.0, USB 3.2 Gen 2 Type A. Get the 3.2 Type A, the Lightning, the power isolation ones, the 3.2 Gen 1, so Gen 2 and Gen 1, 5 gigabit, 10 gigabit, and then we've got 3.2 Gen 1, so 2 5 gigabit plus your Type-C Thunderbolt plus HDMI. And these Type-C Thunderbolt, again, I haven't actually tested it, but theoretically, 99% sure they also do DisplayPort out. So, but look, the memory labels are just 4 DDR5 DIMMs. They don't even say how fast, but theoretically, you know, 8, 9, 10,000 for overclocking should be supported. 4 SATA 3, 1 Blazing Gen 5, 4 Gen 4, and then 1 combo that's PCIe Gen 4 plus SATA 3. So if you do have a SATA 3 M.2, you could do it. Thunderbolt 4, the USB I talked about, 7.1, ALC 4082, Killer 2.5 gig, yeah, because Intel platform. 20 plus 1 plus 2. 20 plus 1 plus 2 plus 1 plus 1, actually. Interesting. Core Ultra Processor Series 2. That is a mouthful. It was upside down for you, but it was right side up for me. Let's see if I can fix that. Let's see. Can I change it easily? Not easily, looks like. Oh, transform. Rotate 180 degrees. Oh, I've messed it up. Look, there we go. Look at that. Now it's fixed. It's good. Is it good? Is it all good? Can you see it? Is it fantastic? Look, 20,000 hour. 100 microfarad capacitors. All right, let's actually pop open the box. Ooh, it's very similar to our Taichi. In here, we've got our Wi-Fi 7 antenna, which is the premium kind, and it's got the stick-on base, so that's good. You'll get the full Wi-Fi 7 speeds. Then here's our board. Oh yeah, this is fancier than the Taichi Lite. Look, you got that rear I/O cover, or not rear I/O cover, the this. Let's see if it's actually thermally connected. Let's see, it's thermally connected right there, or at least there's a pad. And yeah, it's thermally connected at the top here as well. There's a thick pad. Then we got our VRM, and then boom, there's the other side of the board. And then is this? Oh, it is. Look at that. Toollessness. I love the toollessness. And all your M.2 can be lurking under here. Now, I still don't really recommend M.2 RAID, but this does have the Intel VRock solution, which is, if you're going to do RAID, it is the least bad option for boot and operating system RAID on not Linux. And this one, of course, is Gen 5, also toolless. How cool is that? Type 30 or 20 pin, so 2 5 gigabit USB, 10 gigabit USB, 7 segment display, standard ATX, physical power and reset button. We've got a similar fan layout, so 4 pin at the bottom, C3 at the top here, yeah, 1 at the back. Also, easy release for your GPU. So your GPU's here, and then you can just do that and make your GPU let go if you change your GPU weekly. So that's pretty cool. It's like, isn't that awesome? Why not M.2 RAID? Look, you can do M.2 RAID like a RAID 1 is useful. A RAID 0 could be useful, but you go like 3-4 drives, and the overhead of the RAID adds a lot of latency. And generally now, even if you got a slower Gen 4 drive, the thing that makes the computer feel slow is not the transfer rate. It's not because the drive only runs at only 4 gigabytes per second, or only 8 gigabytes per second, or only 15 gigabytes per second in the case of a PCIe Gen 5. It's the latency, how quickly it can retrieve a block of data. And so if you have, 2 drives, that puts you behind the 8 ball in terms of latency, because it's like, okay, this one, now that one, this one, now that one. A little bit of software has to make a decision on which one you want. VROC's actually really fast for what it does. And the penalty's not terrible when it's only 2 drives. When you go like RAID 5 or like 3 or 4 drives, it gets to be problematic. The other thing is that this slot is connected directly to the CPU. So this is very fast. But these go through the chipset. So it has to go to another chip on the motherboard and then from there to the CPU. And that can be a source of bottleneck. And that also means you've got a little bit of latency stacking. So this one will always be your fastest M.2. And the other ones will never be as fast as this Gen 5 M.2. And because of that, if you were doing a RAID 0 or a RAID 1, it can be a little problematic. Now, if you were using this as a workstation or you're a programmer or something, and it's just, I just want RAID 1, you can benefit from that because your writes are mirrored on both SSDs, but the read speed can double. So we need to load a level or something like that. You can read the information, theoretically, twice as fast if both drives were Gen 5. But in this platform, with the limitations, it's actually going to be slower than that. So it makes it a little bit faster when it's RAID 1. And when it's RAID 0, it makes it a little bit faster, but it's asymmetrical. So it's like, it's not fabulous. Two of the CPUs go through, or 2 of the M.2 go through CPU lanes, not 1. All right. Again, this is a preview platform. We can't actually shove a CPU in that. Why then, riddle me this, Batman. Why would only one of them be rated for PCIe Gen 5? Oh, I forgot to change the camera angle. My bad. There you go. So even if what you were saying is true, it's not going to magically make it 5 gigabytes or 15 gigabytes per second because it's not Gen 5. Dun, 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 dun. I actually think using some of your older M.2, so using the Blazing M.2, I've got the Crucial T705. Actually, I've got 6 of them, and they're fast. That is like your operating system or boot drive, and then using some of your older M.2, even in like a RAID volume, even in a Windows software RAID volume, that's okay. That's not a terrible use case. But in terms of I want the machine to feel fast and snappy, for a bootable RAID volume, it's generally kind of hard to do that. If you're on Linux, okay, maybe, but it bugs. If nothing else, it would bug whatever OCD that I might have, not having a symmetrical interface and setup for RAID for my boot volume. But for storage, it could kind of make sense. Let's see what else we got in the box. All right, we got our RGB breakout headers, some more analog sensors. It's another different Cherry style Phantom Gaming MX keycap. Got our Phantom Gaming case badge. It's 2 more analog temperature sensors, some M.2 accoutrement, 4 SATA cables, and boom. There is our breakout card. So this is an ASRock M.2 expansion. Now this is a really interesting card because if you notice there are 4 80mm slots on this, but this is only 4 PCI Express lanes big. 1 lane per card. This is about storage, not speed. Womp womp. It's neat though. It's a neat idea. ASRock's trying something different. I want to try this in a machine like right now, even before the Arrow Lake thing is out. I mean, get a bunch of cheap 1 terabyte drives, throw on this, turn it into a games volume. Okay. Oh, yeah. Yes, I will totally do that. Let's give you an overhead shot. Boom. There you go. Do it again. So, yeah, just 1 lane per M.2, basically. Now, if this were a Gen 4 card, that's going to be 2 gigabytes per second. That's not exactly, that's not terrible. This card does require the motherboard to support this level of bifurcation. So this is going to be a Wi-Fi Nova. This card is likely to only work in very specific motherboards. And I can tell you right now that this madness will only work in the slot that goes through the chipset. The chipset is the only thing that can do this on this platform. I would love to be wrong about that when I actually, have CPUs and do testing. But this is going to be chipset lanes only and 1 lane per M.2. But still, it's neat. I mean, if you're a computer enthusiast, chances are you've got M.2 accumulating, just hanging around. And if you've got a bunch of 256 gig or 512 gig M.2, I mean, why not? Why not throw all those on a card, throw that in, and then just use that for game storage or music or movies or whatever? I'll model with the motherboard one more time. It's the Phantom Gaming Z890 Nova Wi-Fi. And this is a little bit more of a premium board than the Taichi. Remember, the Taichi's everything in balance, and Nova Wi-Fi is, I'm going to go over the top and get all the stuff. And remember, you've got 4 M.2 on board. No, you've got, Blazing plus 4 plus 1. So it's a lot of M.2. This is the board for overkill M.2. Interesting. Now, while I have you, chat, and we're talking about Z890 motherboards, I mean, I get it, It's like, you should actually show me the performance and do the stuff. And it's like, well, I don't know how to make this an interesting video. The only way I know how to make this an interesting video is that we can hang out and chat. So that's what we're doing. But you should also be asking questions like, hey, okay, not the Nova Wi-Fi, but certainly the Taichi and the Steel Legend, which is below the Taichi. You should be saying, hey, I saw your Computex coverage, and you covered the ASRock booth, and there were these LGA 1851 looking motherboards there. And we know about the launch of the new Intel CPUs that are coming up at the end of the month, because Intel's announced that. It's weird, though, because I'm looking at my watch, and it's the end of October. It's almost November. Computex was almost 6 months ago. Not quite. It's a half a year. Do you think maybe? I mean, I'm just yeah. That's a really good point, Rando, in the chat. It sure seems like Intel was going to launch a flagship CPU earlier in the year, and then volume CPUs later. But we didn't get the. Anyway, I don't know. That's probably just a rumor or something made up. Let's talk about the Steel Legend. Look, oh, actually, there we go. Look at that. Z890 Steel Legend. Oh. I don't trust Intel right now. Well, good. You don't have to trust Intel. most of these the components for these CPUs are made with TSMC. So, do you trust TSMC? You're probably fine. All right, Z890. This is definitely the lightest of the motherboards so far. All right, immediately I can tell you, Steel Legend wins on PCIe layout. You've got the X16 slot, Gen 5, then you got X4, and then you got another physical X4 slot with an open end. So we've got 3-ish PCIe slots. Got an M.2 here, got 2 M.2 here with a quick release, and your blazing Gen 5. Yeah, so 2 2280s, another 2280 there, it's 3, and then your blazing M.2. Similar to the other one, it is Gen 5 directly to the CPU, and then all of this, all of this is going to be Gen 4. And then these PCIe slots also go through the chipset. Interestingly, this also has the memory OC shield. This motherboard does not have, heat dissipation or anything on the back. Probably not the board for you if you're going to do extreme overclocking, but I'm pretty sure that this will handle, even the i7 at ridiculous power requirements without any trouble. Oh, and the new processors on paper, again, nothing confirmed because reasons, but on paper they use dramatically less power. So that's going to be interesting. And yet these motherboards still have overkill power delivery for the CPUs. Like, it might have made sense for 14th gen because we know all about the power geometry of 14th gen. But for 15th gen, the Core Ultra, but that's one of the design goals, is to use dramatically less power. And all unconfirmed sources that we have definitely say that that's going to be the case. Get your easily accessible Wi-Fi M.2. So if you wanted to upgrade to Wi-Fi 12 whenever it's out without switching your board, that's an option. 3 4-pin fan headers at the top. Dual 20-pin USB 5 gigabit, so that's nice. USB Type-C, 4 SATA. The bottom edge of the motherboard, 2 USB 2.0 headers. 4 more 4-pin fan headers, analog and digital RGB 5050 headers. Another 4-pin fan header at the rear of the motherboard. Very similar layout. Very, very similar layout to what we've seen from ASRock for the rear I/O. The rear I/O is pretty similar as well. They moved the USB 2 ports. We have a single 2.5 gig NIC. And we still have Thunderbolt and 10 gig NICs on top of that, plus HDMI out. So you get display out via USB-C with these, which is pretty awesome. Dual 8-pin power input. Let's see what else we got in the box. I got a Steel Legend with the Cherry style MX stem. SATA cables, an analog temperature sensor, some ASRock Velcro strips. That's cool. Another notice about the memory O shield patent pending. That's interesting. It's very, very interesting. A sticker to help you with your RF interference. Wouldn't be the first time such a thing has been a thing. Very interesting. I need to resist my urge to shove lots of CPUs into these motherboards and start doing things. I'm really especially curious about the whole, because, again, rumor has it, and looking at the accessory bundles, one would infer that the motherboard, the CPU is going to have to support X8, X4, X4 modes for its 16 lanes. And then we know we've got another X4 from the blazing M.2, the direct Gen 5 interface. Because of that, one would think that I/O MMU and separation on Linux and such might be pretty good this generation. Historically, Intel has had really good I/O MMU separation on the PCIe lanes that are direct from CPU, and they just didn't bother with I/O MMU via the chipset. But it looks like this platform will have some more options, and so be sure to check out the Linux channel for that sort of thing. Like the other boards, they haven't really, for like the rear I/O and the motherboard box features. They haven't really, you get the Gen 5, you get the 3 Gen 4. They haven't really, put any kind of, it's like, okay, Z890, Realtek 2.5 gig LAN, ALC 1220 for the audio, LGA 1851, alrighty. PCIe 4.0, see, it's like PCIe 4.0 X16. It's not X16 electrical, it's X16 physical. PCIe 4.0 by 4 physical. So, interesting. 802.11ba Wi-Fi 7 we talked about. Memory speed. I was looking for memory speed. Where the heck is that? Oh, memory. 4 DDR5 DIMMs. 8,000, 866, 8,200, 8,600, 10,000. How fast is the memory? You think maybe they're still figuring that out. CU DIMMs are a different kind of DIMM that this platform supports, which basically have their own clock redriving circuitry. Well, I can't remember, redriving or retiming. Those are different things. And the memory having the clock circuitry to deal with it means that you can have a much cleaner signal. There are other board vendors that are doing creative things to try to minimize electrical noise and crosstalk. ASRock minimizing electrical noise and crosstalk with a sticker is interesting. It's a bold move, Cotton. Let's see if it works out for him. Won't know until we actually do the testing. All right, chat, what are your questions? We can hang out and chat now. I've got these 3 boards, the Taichi, the Nova, and the Steel Legend, which are my, starting lineup, basically for Z890. So what do you want to know? And also let me know now so that I can incorporate stuff into the full review or the Linux review or the actual, let's put a CPU in it and see what happens. Can't wait for results of stability test. Stability, DDR5, at that speed, it's tough. It's tough to stabilize it, even in ideal conditions. There's a marvel of modern engineering that we're able to... I mean, do you realize, the speed of light is the fastest thing there is? And I know I've said this before, but in 1/5 billionth of a second, light can travel this far, roughly, in a vacuum. Light is the fastest thing that there is, period. And light can get from here to here in 1 clock cycle of your processor if it's 5 gigahertz. That's madness. It's like, oh yeah, 8,800 megatransfers? Psh, sounds good. 8.8 billion megatransfers per second. 8,000 million. I don't know if we're getting any chipset boards. Intel did their Sapphire Rapids refresh. You should check that out. I'm still working on getting my 60-core Sapphire Rapids refresh CPU. I have not gotten that yet, but I got the 20. It's moved from the 24 to the 28 core, or I can't remember. You should check that out. It is a substantial improvement. They fixed the C0 power state on the original Sapphire Rapids, so it uses way less power, but that also means you got a lot more room for boosting and the thermals are better. So yeah, Z890. Z890 is coming in hot. I mean, cool, because it uses less power. See what I did there? All right, let's put my laptop up here where I can actually see it. I believe they talked about empty DIMMs on 4 DIMM boards messing with high-end OC and BIOS. Yes. Yeah, so if you have a board that has 4 slots, it's more problematic to get the 2 slots that you're using, even if you're only using 2 out of 4 slots, running at the highest possible clock speeds, because the wires, the extra wires, are like dangling antennas, picking up all sorts of noise and reflections and everything else. There's another board vendor that said that they changed the geometry of the physical pins in the DDR5 slots for exactly the same reason, to cut down on noise, crosstalk, and reflections. And, you know, it remains to be seen. We got to test the platform. We got to test it and see. I don't, you know, I have seen some complaints about the audio breakdown, but what I did at home was just, I've got the optical SPDIF out into basically home theater stuff, and then that's 5.1, and the home theater stuff. So like I have a set of Logitech speakers, like the Z5500, that I bought, gosh, like 10 years ago, more than 10 years ago. And I'm still using the same set of speakers, but I have another setup elsewhere for reasons. And I didn't have speakers on that. And then somebody was moving, and it was like, okay, I don't want to take this. And this is my old home theater or whatever. And there's a sound bar with a subwoofer and wireless speakers, but it's got an optical connection. And so I was like, wait a minute, optical connection. So I inherited their trash. And that actually works really, really well. That's running off of I think it's a Threadripper motherboard, it's like maybe one of the first motherboards that only had like the 2 analog audio out plus the optical. And it's a 5.1 system off of the optical, and it's fine. And that actually is probably better than the actual analog on motherboard. And the problem just sort of goes away there. Light as a feather, but how stiff are these boards? Well, the Steel Legend is pretty stiff, but it is definitely the most bendy of the 3. The Nova has a metal backplate, which is amazing and thick, and so it's a real chunker. The Taichi also feels substantial, but all of these boards inherit a significant amount of their structural rigidness from the physical heatsink connection. So I don't know. Felix Bruckman, thank you for €5. It's like, hey, what's your take on, is Arrow Lake worth upgrading versus AM5? Also, do the CU DIMMs increase latency significantly? We don't know yet. You're gonna have to wait for the review, because even if I knew the answer, but again, these are chiplet-based CPUs, and so because they're chiplet-based tiles, they're tile-based CPUs. Because they're tile-based CPUs, we sort of know some things about what that does to latency. But if there had been another CPU for this socket that was, going to be released a little closer to Computex, that was monolithic silicon, probably wouldn't have been a problem. Probably. But that's not a thing. But if you're on something that's not AM5 or LGA 1700 right now, then yeah, client CPUs have gotten quite a bit faster in the AM5 generations. The Zen 5 performance uplift was not as much as anybody was expecting from Zen 4. If you daily drive Linux, however, the Zen 5 uplift is pretty significant. Windows 24 H2 just released, which also offers some performance fixes. But it'll be interesting to see the performance here, like what happens with this, because these processors from Intel, these Z890 processors, they are a lot of cores, and they're a lot of very high performance cores. So it's gonna be interesting. How about a brand new M.2 Gen 5 with original mobile heatsinks right now? Is it enough cooling, or does it still need extra heavy heatsinks, or better to get an M.2? So the Crucial T705 is the one that I have the most experience with so far, and it really does want a fair bit of cooling. And I have had it thermal throttle in M.2 slots when they're located under the GPU. The M.2 coolers, where it's just a thin piece of metal, or it's not a substantial amount of metal, can pose a thermal throttling problem. But the great thing about this is that we don't have to be armchair conjecturists. You can install Hardware Info 64, and for the vast majority of M.2 out there, it will tell you if it's throttling. You can leave it running, and it will show you if, like, while it's monitoring, that the drive ever experienced any throttling. So it's easy to figure this out. There is another what? I don't understand. Tell me more. Could you please explain the M.2 GPU PCIe bifurcation for 1x GPU PCIe 5x16, 1x M.2 PCIe 5x4, 2 M.2, 4x4 big. Okay, so I don't think this platform from the X16 slot can turn it into X4, 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 X4. I don't know. We need to actually test that with CPU. It doesn't seem like it can do that. You could do 2 M.2 from the X16, so it's X8, X4, X4 plus X4 from the M.2 that is direct to CPU. So you get 16 plus 4 Gen 5 that we know of. Now, for the rest of the connectivity, you do have some flexibility. It's up to the motherboard implementer to figure out how they want to deal with it. But I don't believe that it's possible to take the X16 lanes and get to an X4, 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 X4 configuration. And you probably wouldn't want to. But 8 Gen 5 lanes plus, then you've got 3 groups of 4, one that is designed for the M.2, and then 2 more that you get from the 8 lanes you took away from the GPU. Like, even that setup, in my opinion, doesn't really make a lot of sense. Like, I probably wouldn't run that configuration. Even if I wanted to run, 2 crucial T705 Gen 5s, I mean, maybe I would, well, maybe in that case. But if I was running like 2 Samsung 990 Pros, one of them could go in the Gen 5 CPU slot, and the other could go in one of the chipset lanes. So, and then the GPU would run at X16. That'd be fine. Patrick Sullivan gave me $3. Thank you. He's a Thunderbolt card on 12900K on Z790. Why is the built-in Thunderbolt lower spec? That is an excellent question. I've harassed the dudes at Intel about Thunderbolt 5, and it's like Thunderbolt 5 is like 2 years late, and I want it to be like twice as fast. We seriously do need an interface that is as easy as USB-C, but that is roughly, I don't know, 200 gigabit, give or take. I mean, think about it. When 40 gig Ethernet came out, or 40 gig, when 40 gig Thunderbolt came out, your network connection was like 1 gig. And there were like really high-end fiber optic things that were 10 gig, and that was 40 gig. Okay, fast forward to 2024, 10 gig is pretty common these days. USB can do 20 gigabit pretty easily. Like, most motherboards that are not the cheapest motherboards have at least one 20 gig interface for USB. 120 gigabit just doesn't seem that fast. Open pleb type C win. Yeah. We'd probably just do it as fiber. Like, it's like, here's your cheap fiber transceiver. 100 gigabit fiber optic transceivers are insanely cheap. Shockingly cheap. So, yeah, that's been a quick look at Z890. I probably should wrap up and go. It's been 43 minutes. I'll go in 45 minutes. What do you got? Any last questions? Anybody have anything else that they wonder about or are curious or whatever? Fun times. ASRock Pay says 2.5 gig NIC for the Steel Legend. Yes, 2.5 gig NIC for the Steel Legend 5 and 2.5 gig for the Taichi and the Nova. Frenzy Man Beast, much respect from West Virginia. There's a small chance we're related if you're from West Virginia. Might have to go back 2 or 3 generations, but oh boy. Alrighty. Well, thank you for hanging out. And look for the reviews that are coming up with Z890, all these boards and more with the Intel launch coming up. I think there's another CPU launch coming up too. I don't know, but hang out and chat and have some fun, and I'll see you in the forum, and good luck with things. I'm going to hold up my cup, and then hit end stream as soon as I see it hold up my cup, because I don't know if the stream ends when I click end stream or if it keeps running for a little while after I hit the thing to end the stream. I don't really know. But it still hasn't shown me holding up my cup. Oh, there it goes.